Very good evening to all. I'm Dr. Pankaj from JSS College of Pharmacy, UP, also convener for Scientific Committee, PharmaNEST'21, which is organized by Pharmacy Federation. So today is the last day of poster presentations. So since last 1 week, we are completed many presentations. So I welcome today's evaluators for this presentation, Dr. Subhas, Dean School of Pharmacy, GH Raisoni University, Madhya Pradesh. Welcome you, sir. Dr.
Thank you,
Madhav
sir.
Divedi
Yes,
from
sir.
Gitanjali University, Udaipur. Welcome you, sir.
Thank you, sir.
Dr. Shankar, Professor, PhD College of Pharmacy, Coimbatore, Tamil Nadu. So we welcome you all. And let us start the session. Sweta,
Thank you, sir. Now I
Thank you.
request eNest 448 to come up with your presentation, and I request Chetan Mehta to share their screen.
Aman, is it visible?
Yes, Chetan.
Greetings to one and all present here today. I'm Sindhu K, final year BPharm student of JCCP UP. I'm going to present my work on the in silico design of epitope-based vaccine ensembles for the COVID FR strain. Here, the FR strain is the France strain which we took for the studies under the guidance of Dr. Raman Rajesh Kumar, Department of Pharmaceutical Biotechnology. Why this in silico design of epitope-based vaccine is here? We took in silico design is it is less time consuming and high effective. And the objective of this study is to design a vaccine of SARS-CoV-2 which has less toxic and higher efficacy. Introduction: the severe acute respiratory syndrome coronavirus, that is the SARS-CoV-2, is of the family Coronaviridae and Coronavirinae subfamily. It is a positive single-strand RNA virus. Presently, the vaccines available in the market are based on the mRNA and the viral vectors to produce the immunity among the community. So, the epitope, as we all know, the epitope plays a supportive role to bind on the surface of the host cell. Furthermore, the genetic material, if the genetic material is extracted from the epitope, it can be used as a vaccine to increase the immunity without causing any harmful effect. Next, we'll move for the methodology. The first step of the methodology is retrieval of the epitope sequence. We retrieve the epitope sequence from the protein database bank, and this epitope sequence is analyzed for the properties like antigenicity, non-toxicity, non-allergic properties, and then this epitope sequence is furthermore studied and the atomic formula, number of atomic amino acids, theoretical PA, negative residues, positive residues, the instability index, aliphatic index, hydropathicity, the antigenicity also has been studied. And then the selection of the antigen binding peptides. The selection of the antigen binding peptides are the T cell and B cell peptides. We took this from the protein data bank from the IDVI. Here the MHC1 and the MHC2 and the linear B cell epitopes were extracted, and these are studied and selected based on the physicochemical properties such as antigenicity, non-toxicity, non-allergic, and the analysis were taken place. And then the third step, the adjuvant selection. Here the adjuvant selected was the C-lectin. The C-lectin is the protein adjuvant selected, and this also has been subjected to the physicochemical property studies like antigenicity, non-toxicity, non-allergic properties, and non-toxic studies. These both adjuvant and antigen peptide binding proteins are fabricated into the vaccine by using the linker codons of the MHC1, MHC2, BCL linear B cell epitopes. And then the molecular docking is done. Before that, the structure prediction and analysis is done for the fabricated vaccine. The structure prediction and analysis, the 3D structure of the fabricated vaccine were subjected into the NMR spectroscopy and X-ray spectroscopy. And then the Ramachandran plot also were being studied for the amino residue studies. And then the molecular docking were done. Here the molecular docking, the TLR receptor has been extracted. The COVID-19 strain act on the TLR receptors such as the 3, 4, and 7. We have docked the TLR receptor like 3, 4, and 7 with the fabricated vaccine, and then the results were got. The docking studies global energy were minus 31.96, which is a good docked result. And then the molecular dynamic and immunostimulation studies has been done. Here the molecular dynamic studies are done, and the immunostimulation studies also has been done for the confirmation of the immunity studies, which is the ultimate goal. Here in the I request to zoom into the pictures. Here the molecular dynamics. First, the deformability studies has been done, and then the A10 value. The A10 value is to represent the energy required for the deformability of the structure. And then the immunostimulation. The immunostimulation, the antigen value, the antigen count per ml, and the IgG, IgM, and IgG1 and IgG2 has been studied by using the software. And here the red color is IgG2, the pink color is IgG1, the green color is IgM, and blue color is IgG1 and IgG2. IgM and IgG is represented in yellow color, and the antigen is represented in the black color. As in the 50 to 100 days, the IgM and IgG value has been increased. That is the immunoglobulin M and immunoglobulin G is increased up to the 7 lakh count per ml, which is very good result. And then I would like to move on to the result and discussion part. So the result and discussion part. The fabricated vaccine seemed to be a good vaccine candidate for the SARS-CoV-2 because of its physicochemical properties such as antigenicity, non-toxicity, non-allergic properties, and the analysis like Ramachandran plot, NMR, and X-ray spectroscopy has been shown a favorable result for the vaccine. And docking studies, immunodynamics, and immunostimulation studies are also shown prominent effect and the clearance. And so the in silico method was done, and in vitro and in vivo studies has to be done further for the better toxicity studies. And I conclude this is an effective vaccine model which can promote for the clinical trials and determine the in vitro characteristics. This model can be useful for the researchers and scientists to develop this method to fight against the resistant microorganism and to develop vaccine against microorganism that has no cure yet. And these are the reference. And I thank my guide, Dr. Raman Rajesh Kumar, the supporting staff, organizers, and one and all present here, and for giving the wonderful opportunity to present the poster presentation in Operant Pharmacy Federation, PharmaNEST'21. Thank you, and I don't present here for patient listening. Thank you.
Thank you. Now I request all the evaluators to come up with their questions.
So what is your title? Is an epitope for COVID first strain. Okay. So how you designed the epitope? On what basis you have taken the epitope?
It is extracted from the protein bank, like NCBI protein data bank, sir.
Okay. Then you subjected it for?
And then we subjected for the physicochemical properties and stability studies of the sequencer.
Okay. So how many, what is that sequence, or how many molecules you got it during your docking study?
We got several results, sir. The best is CLR 3 with a global energy minus 31.96.
Okay. So how you came to a conclusion that this will be very effective? Only the 32 score. There is only one. No, the 32 score. With that you come to conclusion, or no? How you confirm from the different molecules this molecule is effective?
So we segregated non-toxic one and the toxic one, sir. Only the non-toxic one are subjected to the further studies, and
Okay.
then we got like 7 lakh antigen, sorry, 7 lakh IgM and IgG per ml, sir. Between the dates of 50 to 100. And then the immunostimulation studies were done in the software MSIM, sir. That's 3 doses for 4.2 weeks with a count of 1040 units, sir.
1040. Okay, thank you.
Hello. Hello. Am I audible?
Yes, sir.
Yes, sir.
I just want to know, where did you perform the studies?
Sir, everything in computer, sir.
Huh?
Computer, sir.
Okay. On computer only you have formulated. Okay. What were the confirmation studies for non-toxicity or any all other things, parameters?
So every parameter has a different server in internet, sir. Antigenicity, non-toxic, all separate server in the set, sir.
But the things that may be non-toxic on the computer modeling may be toxic in the in vivo.
That's what, sir. In silico method, till now it is a good candidate, and then in vitro it has to be done for the toxicity studies, sir. And
Okay then. Thank you.
Hello.
yes, sir.
In silico method, which software you have used to study this data to get your result? Is there any software in computer or just a literature search?
Sir, we have searched like 32 literature and research papers, more than that, but segregated a good 32 literature services. And then for particular study, the particular server is best, and then we segregated and made into a model, sir.
My question is that suppose we have some softwares to feed the data in a particular software and get results. Is there any software you have used, or just use the literature data to get your results?
Yes, the sequence, starting from the retrieval, the immunostimulation research, everything has been implemented into the server or the software, and then the results are obtained, sir.
Okay, thank you.
Okay, thank you.
Thank you.